Hey everybody, this should be the last of the videos for the multi-factor ANOVA. So I want to do the 6 steps of hypothesis testing, and the study that we're going to use for the 6 steps is different from what we've been talking about. This study is actually a 3 by 2, and remember what that means. I'm talking about 2 numbers, 3 by 2, that's 2 numbers. So that tells you that we have 2 independent variables. But the number of numbers tells you how many levels of each independent variable we have. So 3 tells you that we have 3 levels of one independent variable, and the 2 tells you that we have 2 levels of the other. So in this study, we're looking at the impact of caffeine and sleep on mental alertness. So there is going to be 3 levels of sleep deprivation, 0, 1, or 2 hours of being sleep deprived, and there's going to be 2 levels of caffeine. So people are going to either have caffeine or not have caffeine. So the idea here is that perhaps being sleep deprived is going to decrease your mental alertness, and that perhaps having caffeine will help you retain that alertness. And maybe the 2 independent variables will interact in some way. So because of that, we're going to be looking at really 3 different questions. Does caffeine affect mental alertness? Does sleep deprivation affect mental alertness? And then do the 2 independent variables combine? And so because of that, obviously we have to do a multi-factor ANOVA. So again, let's go through the 6 steps. All right, here are 6 steps that we always use. The first is pick a test. We have 2 independent variables, so we know that we're not doing any t-tests, any z-tests, because all of those did 1 independent variables. We're not doing the one-way ANOVA. A one-way simply means that we've done 1 independent variable. We're not doing a repeated measure ANOVA either, so we know that we're doing a between subjects 2-way ANOVA. We're doing a 2 by 3 again. We have to check our assumptions. These are things that we've done in the past: random samples, independence of observations, normality of that dependent variable, also that there's homogeneity of variance in our dependent variable. So we're going to say that our that everything was satisfied. All right. And we're going to go into step 3, and that's listing our hypotheses. Now this is new because in the past we've just had to list a null and an alternative. But remember, this ANOVA is looking at, if we're doing a 2-factor ANOVA like we're doing here, we're really testing 3 hypotheses in one: the impact of both of our main effects as well as the impact of our interaction. So yeah, we have to do a null and an alternative, but we have to do that for both of our main effects and our interaction. So we have 3 sets of hypotheses. So the effect of our caffeine, null and alternative; the effect of our sleep deprivation, null and alternative; and then the effect of the interaction. Okay? So just like that, we have to find our decision rule. We have to find out what that value of f is that is going to determine whether we can reject the null when we calculate our observed value of f. So we're going to potentially have 3 different values of f. So we had to figure out the decision rules for our row effect, which is our caffeine consumption, our column effect, which is deprivation, and then the interaction. All right. And just like we found our value of f previously, we have to find information based on our study's design. So we need to know the degrees of freedom for our study. So let's look at all this stuff. It's going to give you a headache for a second, so just bear with me. Here are all the degrees of freedom. So degrees of freedom for our rows. What are we talking about rows? Well, we're talking about our row variable. So it's the number of rows we have minus 1. Basically the number of groups you have minus 1 for that variable. Same thing for our column. How many groups do you have for that variable? Minus 1. And then the interaction is the cross product of that. We also have our within subjects degrees of freedom. That's the total number of cases minus the number of rows times the number of columns. So in this particular study, we have 3 rows and 2 columns, or 2 rows and 3 columns. So it's total number of cases minus 6, for example. So here we have everything. Our row main effect, that is caffeine. So we have 2 levels of caffeine, minus 1 is 1. Column main effect is deprivation. That is 3 groups, minus 1 is 2. So 2 times 1 is 2. That's our interaction, all right? And then our within group effect, that's our degrees of freedom. That's our total number of cases, which for this study, this example is 60 cases, minus 6, that's 24. So to find our critical value of F for our 2 main effects, as well as our interaction, we need to know our degrees of freedom for these and our within, okay? So for 1 and 24, for 2 and 24, and for 2 and 24 degrees of freedom. And then of course we also need to know the alpha level that we're using for the study, which is always 0.05, unless I tell you otherwise. So we go to the back of the book and we find that information. So with an alpha of 0.05, with 1 and 24, 2 and 24, and 2 and 24 degrees of freedom, here are our critical values of F. So now we can calculate our test statistic. And I'll let you know that I have had my class do this in the past by hand. I'm not having you guys do this. It's a lot of work and it's really difficult to do, especially in an online class right now. So what I want you to know how to do is understand where the numbers are coming from. Okay, I want you to be able to read an ANOVA table. So just like the other ANOVAs, we have the same columns. We have our source of variability. Again, why is that important? Well, analysis of variance, okay, and ANOVA is analyzing the sources of variance. It's wondering, okay, the dependent variable that we're measuring, all the variation in those scores from our participants, where's the variability coming from? Is it coming from our independent variables, the interaction between them? Is it coming from just error? So on and so forth. So we need to understand that and figure that out. So that's what ANOVA is doing behind the scenes. So we have our source of variability. We then have our sum of squares, our degrees of freedom, which we just figured out how to calculate. Once we get these 2 columns figured out, everything else is easy. Because a mean square is a fancy word for variance. A mean square, the generic formula is always a sum of square over degrees of freedom. So the mean square for our row variable is always our sum of square for row over degrees of freedom for row. Mean square for our column, sum of square for column divided by degrees of freedom for column, so on and so forth. And then our F ratio is always a mean square for our factor over our mean square for our error term, which in this case is our within groups degrees of freedom. So here are 2, here are 2 independent variables, our row and column factors, and then we're going to divide by the error. Give me 1 moment, I'm going to let him in. He's going to bark all day. All right, now I've got dogs all over me. Okay, so an F is a mean square over another mean square, okay? That's how we get F. So the data from your book, let's just get to it. Here is everything. So I want you to understand where these numbers are coming from, at least how we're getting everything over here. This is what is difficult to calculate, and this is what I'm not going to have you calculate, okay? What I want you to know is that this total sum square is always going to equal the sum of all of this. So if I were to remove on an exam one of these values, you should be able to figure out what that value is, okay? We know how to do the degrees of freedom because I talked you through that. Again, once you have these two columns, you should be able to find everything else, because the mean square for your row is a sum of square divided by its degree of freedom, which is why 3630 divided by 1 is 3630. And our column 1340 divided by 2 is 670. And 980 divided by 2 is 490. And 748 divided by 24 is 31.17. Now, in this ANOVA, our within groups is our error term. So this is always our denominator for our F statistic. So when we're doing our F ratio for our two main effects, as well as in our interaction, the F is always equal to a mean square over another mean square. So 3630 divided by 3117 is 11646. 670 divided by 3117 is 2150. 490 divided by 3117 is 1572. So those are our observed values of F. Again, what we do is compare these to our critical values of F that we had earlier. These are all greater than that. So we know already that we have rejected the null. So our sixth step is always to interpret the results. So we're going to answer three questions. Was the null rejected? And it's not just was the null, but were the three null hypotheses rejected? If we say yes, we have to answer how big the effect size was, and then we have to ask where the effects are and what their directions are. So I think I'm going to have one more video to explain all of this, and then that should conclude the multi-factor ANOVA. Again, if you've got any questions, let me know. Email me at asikorsky@talmud.edu. Take care.